here is the Python script that I sent you. And I copied it to my folder and I double-clicked it, and it opened automatically here in this IDLE program. Here's an organization of some commands that we had in our transcript in our Python window that I then saved, and then I cleaned it up. I deleted a couple of lines and made it what it is now. And so here you recognize a whole bunch of commands that you're familiar with now. The first thing is we want to import ArcGIS just to make the rest of the commands easier. We set our workspace, in my case here with the R in front of my quotation marks. In my case it's quite a long one, doesn't matter. Here is one new command, override output equals true. So when I do that, it overwrites existing files. That can be both a blessing, but also can be a curse if you overwrite files that you want to keep. So be aware of this. And sometimes it would be safe to copy this line and end it at the end and set it back to false. So then it only runs for your script, but it's not permanently set off for the rest of your session. Here I am setting a feature class. An FC is just a variable. I set it to our schools shapefile. I'm defining an out prefix called school. And now we're applying here what we had earlier done for our rivers. We're applying a distance list and we're putting it into a for loop. Our out name is concatenated here. And our distance is a variable that comes from the distance list. Then I'm printing simply out here to this window, creating, and then out name. So it tells me that it's busy doing something. And then once it's run 3 times, it comes to an end. And I like to add at the very end of my code simply a message to myself that really the program has reached the last line. And I like to make fun of myself, or I tease myself, or whatever you want to put in here, something that's uplifting and gives you a smile every time you see it. Let's run this file. We run this file now without having ArcGIS open, and I'm running it here, run the module. Source must be safe. So here now, another window opened. It's called the Python shell. This is communicating to us what's going on. So it will give us some commands here in a while. It just takes a little bit to get going. So now it's already saying here, creating buffer. That comes from our print command. So it did first the 1000, then the 5, then the 200, and it came up to an end. All done. Because this is a standalone program, it doesn't display anything. ArcGIS Pro is not open, but it still created the files and they are in the folder that you had set for yourself. So we tested the script, it works, but really this is not a proper script yet because we haven't added any comments yet. And let me show you what kind of comments are useful, especially for beginners. I'm just copying, pasting some comments in here. So here I'm starting off by simply saying, what does this script do? It buffers the education points, distance in a distance list, and then you change your date. I'm just adding a blank line for myself, and now I'm just adding a header here that says import. Let me just make this clearer. Import ArcGIS and set workspace. So this is what the first parts are doing here. So this is basically the setup in a way, the top part. And then you remember, okay, this is what I have to do first. This is my settings. The next header could be set the variables and define a distance list. So here I'm setting variable, another variable, the distance list. And then I can add here just a comment to myself. Loop through each distance. That tells me what it does. And then what I like to do with loops, especially when I give them already a header, is to tell myself where the loop ends. So that's clear. Everything inside here goes around. And then outside the loop is your message to yourself. Now you want to save this file, and you can also add more comments for yourself if you want to. But to do that is it helps you to organize your thoughts, setting variables, then doing the analysis in a loop, and message to myself at the end. And all scripts you write will follow the structure. Here's another example of a Python script called define projection.py. Projects all feature classes within a folder. Who wrote it? First version, and then I made a change then, so it's nice to keep an update of that. What kind of changes made, especially when changes were made by multiple people. And then some headers here, the usual that we are familiar with. And all we're doing here is a feature class list, which is made up of all feature classes found in this folder here. And then simply a for loop that in this case defines projection for all of those. And then simply listing the feature classes in here. And all we need to do here now is run this. And here's our shell window, and it found these 4 shape files that were now defined. I write myself the end text. You see why I separated my own message here from the bottom in case there's a lot of communication to the screen going on. And so this just makes it easier to see when a program is finished. The longest program I've ever ran for 94 hours. And so there, of course, you were very, very anxious to see if this last line actually ever happened. And in our case, we were lucky it did. It ran to the end and it produced what we were hoping for. Another way now how you see the organization of the Python scripts. The remaining drawback is that within the IDLE window, we cannot provide automatic input. So we have to hard code everything, and we cannot add parameters. Let's write a Python script that requires raster analysis. I've already started here with filling out the normal header information, nothing new here. And the first thing I have to do for the proper geoprocessing is I have to create a raster object. What I'm doing here is I'm creating a raster project, just a new variable called lf_raster in my case. By using the keyword raster in front of my actual raster file, I am creating now an object called lf_raster that can be used for map algebra and any other subsequent raster operations. It contains the same information, the raster cell size, all the objects that are inside the original raster, but for Python scripting, it just simply puts it into this new entity. In the online help, the raster objects are discussed, and we can learn the syntax just how we have applied it just now. And again, a reminder that the new raster object is only temporary in nature, and in order to make it permanent, we can save it. Let's do a quick slope calculation from our input DEM, so using that raster object as an input file. Here in my slope calculation, I am simply calculating the slope input raster, and then the next variable would be, is it in degrees or is it percent rise? And the first option is that it's in degrees, so therefore the degrees is a default option, and I already have signified that my result will be in degrees because I put the output raster file is called slope in degrees, just as a reminder of that. Then I would like to do some selections between both a certain elevation and a certain slope to do a very simple constraint analysis. And I'm declaring two new variables for the value for the slope and for the value for elevation. In this line here, we're creating a new output raster called select slope. In this line here, we're creating a new temporary raster file called select slope. If the slope degrees are over or equal 10, the raster cells get a 1. If this condition is false, the cell values will be 0. The same selection process here, creating a new raster output file. Select elevation equals 1 if this is true, and 0 if this is false. Now we're combining the two selection rasters. So here I'm creating a new raster file that will be a 1 if either of these are 1 and a 0 if any of these are 0. Let's create another alternative output file where we add these two together. So wherever we have both conditions would be a 2, and where we have none condition would be a 0, and where we have either condition being true, then we have just a 1. And here I have to again make new raster objects for my calculation, because I'm doing map algebra now with a plus sign, not with a selection. And so my syntax looks slightly different. I need to type the raster keyword first. This code here will simply add these two raster files up, just like in a raster calculator, except the syntax is different. These are all temporary raster files, and to make them permanent, we simply have to apply the save command. So I'm choosing temporary raster file, and I say save. Now I can declare any output file name I want. I want to use the same name. And I'm double checking my spelling. And at the end, I write a message to myself. I forgot the quotation marks. And so in order to avoid that my apostrophe is not interpreted poorly, and as the end of my print statement, I have to add my R for raw so that this message will be delivered as is typed in here. Every time you're using a geoprocessing tool, and especially every time you're combining a string of tools, like in this kind of code here, we need to carefully check all of our results, ideally in the sequence how they were calculated. And right now I think it's a good idea to put my hill shade on top of all. That helps me to understand the terrain better. My first derivative is my slope. The darker the color, the steeper the slope. Then we have derived the slope from here, simply saying slope over 10 degrees. That is the darker areas. That also makes sense. The other query was select elevation above 1500 meters. And we can see that this line here between the below and the above 1500 meters is following this contour line over here. So that also makes sense. Then we have our selected slope, and with the AND command we also add in the condition that it must be above 1500 meters, and here you see how that is correctly achieved. And lastly, our add command, you see now here the colors have changed for the different categories, and I can correct that. And after we use the same colors for zeros, and in this case 2 is following both conditions, so same colors in this case, and now we have either 1 is 0 or 1, and here now we have those areas that are above 1500 meters and a different slope, or below 1500 meters and have a slope of over 10%. So with this final check, we are satisfied that the logic of this script works. And now we're ready to take the next steps and do some further coding, especially make the hard-coded variables such as the input file and the degree value and the elevation values to be selected, and also the output file names, to make those all variables. And I will show you how to do that using the IDLE editor in terms of coding. And then we need to import that into our import scripting tool in ArcGIS Pro. That's all for today. Until next time.